Yeah, R minus will be there, Mg plus organometallic compound. The carbon, magnesium, carbon, metal bonds are there, and these carbon metal bond, carbon will be negatively charged because metals are electropositive. The electronegativity of magnesium is 1.2, okay, on the Pauling scale, and the carbon is more electronegative. It has got 2.5 value of electronegativity, so carbon will have minus. So any idea what's going to be the answer to this one? Then we can discuss the mechanism, and that will make everything clear to you. Yeah. So 2 more carbon atom, where you will have 2 more carbon atom. That is going to be, yeah, answer is going to be option B. Okay. And this is cyclic ether known as epoxide.
Yeah.
Okay, epoxide. And I will quickly tell you, suppose this is what we discussed in the last class. So just quickly we can go through it very quickly. So if you have a ketone, and if you take Grignard, so the carbon minus of the Grignard will attack on the C double bond, carbon of the C double bond O, because it is positive. Oxygen is electronegative, so carbon is positive, so R minus is going to come and join itself to the CO. And because the carbon can make only 4 bonds, so you need to remove one of the pi bond and put the electrons of that bond on oxygen, so oxygen will become minus. So this is going to be the answer of this. Okay, so O minus MgBr, and when you put water, it will become OH. So it will be RCH2OH, right? So if you want an alcohol from Grignard we took was RMgX, you got alcohol, primary alcohol with 1 more carbon atom. You need to react it the Grignard with formaldehyde. Okay. And suppose if you take a ketone and if you react it with RMgX, so R minus again, it is going to come and join in on the carbon of the CO because it is having the plus charge. Minus will get shifted on O, the pi electrons, and you will get a tertiary alcohol. So this is what we discussed in the last class. Quick recap. So ketones will give a tertiary alcohol. Okay. And formaldehyde or methanol is going to give primary alcohol, right? And any aldehyde other than formaldehyde, it is going to give you secondary alcohol because CH3 CHOH. Okay, this will become OH and R. So it is going to be secondary alcohol, 2-degree alcohol because it is connected to 2 carbon. But what will happen to epoxide? Epoxide is actually a very small ring. It is under pressure. It wants to break. So suppose if you take R minus Mg X, okay, plus Mg2 plus and X minus. So R minus is going to come and attack on the carbon because it is delta plus, still delta positive, because being connected to oxygen, it will have partial positive charge. And the ring also wants to break. So the ring, the pi electron density will get shifted to on O. The ring will open up. So you will have R, which is attacked on 1 carbon of the ring, epoxide CH2, and this bond will break, and the bond electron density will get collected on O, and O will become O minus MgX plus MgBr. MgBr will come along with the O minus because now O is minus, and when you put water, it will become OH. Okay, so ultimately you are going to get RCH2OH. Is it clear? So if you want to get primary alcohol having 2 more carbon atom, you need to react it with epoxide, and epoxide is the general class of compound. This is, the name is oxidane. It is having a common name of oxidane or ethylene oxide. This is the common name of this. Okay. If you want to get a primary alcohol with 1 more carbon atom, you need to get reacted with formaldehyde. So I hope it is clear. Any doubts on this?
Yes. No.
Yeah. So this is also the same question. Just you can try it very quickly. 2-phenyl ethanol may be prepared. You can try it very quickly. 2-phenyl ethanol. Now they have given you the name instead of telling in a general way. So what's going to be the answer to this one?
One second.
Which one? Yeah. Okay.
Options.
Yeah, option C, correct. So yeah, phenyl ethanol, yeah, PHMGBr you took. And you took this one. Yeah, correct. pH minus is there, phenyl is there, and this is going to be pH CH2 CH2 OH, right? So this is ethanol, and the numbering will be done from here 1 to 2 phenyl. So another method for the preparation of alcohol is by reduction. Okay. So reduction you can do by catalytic hydrogenation. This is the most common way of reduction. Most common way. It is used everywhere. Right. So you take catalyst PT, PD, Ni, ruthenium. Nickel is a very reactive catalyst and it is mostly used at many places. Platinum is also used. Nickel is the most reactive. So you can see these, all these double bonds are getting, HH is getting added and it is changing to alcohol. So aldehydes will give primary alcohol because 1H is already there. So 1H will get added, so it will become CH2. But ketones are going to give you secondary alcohols upon catalytic hydrogenation reaction. Is it clear? And what about this one?
Yes.
Yeah, what about NaBH4 and LiLH4? NaBH4 and LiLH4, which one is stronger and which one is mild reagent? What is the name for NaBH4? Okay, it is mild reducing agent. It is not as strong as LiLH4. It is mild reducing agent, and because it is mild, because hydrogen is actually it is like this. It is hydride donor. Okay, what do you mean by hydride donor? Any idea? Means it is going to give you H minus because one H minus is extra. You can think in terms of the formula. The formula is BH3 and H minus is extra connected. So H minus is going to come out, and where the H minus is going to attach itself on the carbon having the partial positive charge. Okay, so it is going to come here. H minus is going to come and attack here, and finally after that you will take some water or something. So that the O minus get changed to OH. And it is mild reducing agent. It is because weak reducing agent. It is because sodium boron bond is stronger. Boron is small atom, hydrogen is small atom, so they are less reactive. Okay. So nitro group is not reduced. You can see the only it reduces NABH4, reduces only aldehydes and ketone that you can write. Okay. So NABH4 is there. You can see the same here. The aldehydes are going to give you the primary alcohol, and the ketones are going to give you the secondary alcohol. Okay, same thing. But other functional groups like carboxylic acids, or esters, amide, esters are RCOOR dash. Amide is RCONH2. Anhydrides RCOOC. They are not reduced by or double bond, carbon-carbon double bond, and the carbon-carbon triple bond. Carbon-carbon double and triple bond are non-polar, are not reduced by NABH. That you can note down. Okay. Only aldehyde and ketones are reduced by NABH. Is it clear?
Yes.
LiLH4 is strong reducing agent, and it reduces aldehydes, ketones, and carboxylic acid, and the other derivatives of the carboxylic acid are also reduced. For example, esters, amides, and all. But the double bonds are still not reduced. You can see. So the double bond is still intact. H minus is going to come and join here. O minus is going to form, right? And it is going to form CHOH. So ketones are going to give you secondary alcohol. Carboxylic acid, suppose if you would have taken NaBH4, the answer would have been no reaction. Okay. But if you would have taken LiLH4, the carboxylic acid will get reduced to primary alcohol. Clear? Similarly, this is also carboxylic acid. But here also we can see that the double bonds are not getting reduced, only the carboxylic acid is getting reduced, and that too with LiLH4, not with NaBH4. NaBH4 will not reduce it, and we can get a good yield. Okay, so this is the question from the NEET 2000 paper. What is going to be the answer to this one? Yeah, Memuna. Any idea what's so LiLH4 reduction by LiLH4 and hydrolysis? Yeah. A, B, C, or D?
A.
Yeah, it is going to give you two alcohols. Correct. Very good. So it is, suppose if you have CH3CO OCH3. So what's the mechanism? So first, LiLH4 actually is, suppose if you take NaBH4, the answer would have been no reaction. NaBH4 is mild, so it will not react, it will not reduce. LiLH4 will reduce, and LiLH4 is a strong hydride donor, which means H minus, and this H minus actually is a very strong reducing agent, and you can note down that there are 4 H minus on the aluminum. So first H minus is going to act like a nucleophile. It is going to come. Initially, it is going to push away the minus, and that minus actually come again, and it pushes out OCS3. So first step is CH3, COH, and OCS3 minus. But LiLH4 has more hydrogens. Okay, it is not just having one hydrogen, so it reduces this aldehyde again until all the double bonds are reduced. So CH3, CH2O minus it will form, and when in the last step we put water, so CH3, CH2OH, and CH3OH. So what you are going to do, you are going to demarcate like this. So this is the alcohol of one carbon atom, and this is also going to become alcohol of two carbon atoms. Okay, so that can be asked that whether it is going to give you one type of alcohol or two different types of alcohol, that also can be asked. So just you can quickly check. Okay, but with NaBH4 it is not going to react. Okay, this is the trick. That's what we discussed now. Just now this. So this, it will come out like this. So this is going to be the methanol, and the left hand portion is going to be the propanol. Okay, carboxylic acid is going to give you primary alcohol. Ester is going to give you two alcohol molecules. They can be either same or different. That depends upon the nature of the ester group. Aldehydes will give primary alcohol, and ketones will give secondary alcohol. And this is the summary of the reduction. Okay, which we did. So this is the preparation method
Yes.
of alcohols by reduction. Okay. Yeah. Let's do this. And this is from 2012 paper of NEET. Just a second. So first we are treating it with KCN. Then H3O plus.
Is it ethyl alcohol?
Yeah, it is going to be ethyl alcohol. So first is SN2 reaction, substitution nucleophilic bimolecular SN2. So Br is going to come out CN, CH3, CN. And what you are going to get if you do the hydrolysis of CN? Just take water, put HOH, HOH, complete hydrolysis. This is the shortcut, not the mechanism. Do it like this, and you are going to get a carboxylic acid. You will have 3 OH groups. This is just a shortcut, not the mechanism. You remove water out of it because so many OH groups, 2 or more than 2 OH are unstable. So you are going to get CH3, C double bond O, OH. That is going to be the structure of B. And when you take to LiLH4, this is going to get reduced to ethyl alcohol. So D is the right answer. Good. So, and what are the methods by which you prepare phenol? And this Dawes process, clear? So Dawes process, what you do? You take chlorobenzene, okay? So the mechanism is which one? SN1, SN2, or SNAR? It is neither SN1 nor SN2. Okay, it is SNAR. It is bimolecular nucleophilic substitution, and it happens in this way that we discussed in alkyl and aryl halides also. Is it clear? Any doubt in this? NO2 at the para position is going to increase the rate of the reaction. Okay. Clear? So initially OH will
Yes,
attack
sir.
and this mechanism, this we discussed in that. I'm going very quickly through this because we discussed in halide chapter. But if you have any doubt, you can stop me anytime. Not a problem. I will explain it again. And yeah, so you can, this group, electron withdrawing group at ortho and para position makes the ring bring the positive charge on the ring, and that's how the ring become more reactive, and the reaction becomes easier and easier. Okay, so you can see here it is just by warming it has happened. Okay, so this is Dow's process for the preparation of phenol, but you need to have chloro group already connected, that you need to connect by electrophilic aromatic substitution. Then only you can have it. Okay. And this is the preparation by sulfonation. You can do the sulfonation. Sulfonation, how you do? By treating with conc H2SO4. Concentrated H2SO4 or SO3 also you can take. Either you can take sulfur trioxide or SO3, any one of them. You will have benzene sulfonic acid. But if you take nitric acid and concentrated H2SO4, that is going to be different. Okay, that is going to be nitration. Is it clear? And
Yes.
once you have benzene sulfonic acid, you heat it with OH, and the same mechanism will happen here also. That bimolecular NAS, bimolecular nucleophilic aromatic substitution, that SO3 is going to come out. Okay, same reduction is going to happen. So this is the preparation of phenol via sulfonation. Very, very important method. Many students forget it. Okay, so do remember this. This is very important. But first you need to create benzene sulfonic acid by doing the sulfonation of the benzene ring. Okay. And next is the diazonium via diazonium. So diazonium we already prepared. How we prepared? We did nitration. We reduced nitrobenzene by 10 HCl, and we took NaNO2 plus HCl 0 to 5 degrees Celsius. Okay. Or sometimes it is written as nitrous acid. Okay. So actually that NH2 is going to get changed to diazonium salt, and that diazonium salt, when heated with dilute H2SO4 or H2O oil, the water nucleophile comes in and attack N2 leaves. Okay, the water comes in and attack. Yes. Okay, so you have that phenol. So I hope this is clear to you. Right? Any doubts in this? Benzene diazonium salt. Any step which needs explanation, the formation. This we actually did in aryl halide chapter also. So, but if you want, I can explain you. Clear? And yeah, this is cumene hydroperoxide method. Okay. So, what do you understand by cumene hydroperoxide method? What is cumene? What is the common name for cumene? Memona. Cumene is actually
Yes, sir.
isotope. Yeah, what is the common name of cumene? This was clear, na? Diazonium. Any
Yes.
doubt? Yeah, okay. Any doubts you can tell me, because we discussed in that Sandmeyer, Gatterman. Okay. Let me know. So, what is the common name for cumene? So you can prepare the phenol by cumene also. Okay, preparation of phenol by cumene hydroperoxide method. What is the other name for cumene? It is what? Isopropyl benzene. Okay, this is isopropyl group. Okay, and how it is formed? This is alkyl benzene. Okay, alkyl benzene, how it is formed? Any idea?
No.
Yeah. Okay, this is prepared by Fieldcraft alkylation. So either you can take C isopropyl chloride along with the AlCl3. Okay. So what AlCl3 will do? AlCl3 has a vacant p orbital. This I'm putting it as a box to make you understand that it is an electron acceptor. So it accepts Cl minus. Okay. And Cl minus it is taken away by the AlCl3 and it becomes AlCl4 minus, and you are left with a cation. Okay, and this cation goes and attack the benzene ring. It takes the electron from the benzene. This is isopropyl cation. Isopropyl, so I'm writing it in a short manner. And because the benzene pi electron is pulled out, there is H also. They were there, but now I'm writing it. So there will be plus charge, right? And okay, so this is the intermediate which is formed, and the Cl minus which was taken away by the AlCl3, that is going to come out again because AlCl3 is a catalyst. You need to get back the catalyst. It is not consumed, and the electron will get H plus will be removed. So HCl will form, and so this is known as Fieldcraft alkylation of the benzene ring. Okay, so that's how you can get the isopropyl group connected on the benzene. Or there is one more other way. So both the ways can be given. Both are very, very important. The other way can be you took the benzene and you took propene. And you took some acid, let's say H3PO4, which gives H plus. So acid will give H plus will get connected to CH2 plus. Okay. By Markovnikov addition. So you are going to get the cation, isopropyl cation, but by different way. Initially you took chloride and the chloride was removed by AlCl3. But in the second one you took the alkene, you added H plus by Markovnikov way, and you created isopropyl cation. Okay, that cation will again, now the mechanism will be same. The cation will go and attack on the benzene ring. Okay, and that will form a plus, right? And finally you will have this intermediate and H plus intermediate. So you will have isopropyl benzene, which is known as cumene, right? Then you react it with oxygen and H nu. Okay, what it is happening? Oxygen has 2 electrons. It is a biradical species. Oxygen actually breaks this hydrogen and get connected So this hydrogen can be broken very easily because of the resonance. It's very reactive. Its bond energy is very less. So an odd electron or unpaired electron is left behind when the hydrogen is taken away by the oxygen molecule. So it is OOH. And there is another electron on OOH, and they combine together to form this. So this is peroxide linkage, because O linkage on one side it is having cumene, another side you are having hydrogen, so cumene hydroperoxide, and that is the name of the intermediate, and this is the name of the reaction also. Is it clear?
Yes.
And now what you do the hydrolysis, H plus H2 dilute H2SO4. So water breaks apart. This OH gets the H plus from the water, from the acid. It breaks apart, and this benzene ring is shifted. I can just a second. This is the pH. The OH will be removed. Okay. And it will leave behind a cation. Actually, this will not form immediately. This will get shifted. The benzene is electron rich species, and it goes and join itself to the O plus. And benzene goes away with the electron pair, so now the plus charge will be on the carbon. And the benzene will be okay. With water dilute H2SO4, it breaks further. Okay. It breaks further. Okay, right? So initially you get OH connected. I will write it completely. OH with water. The cation attacks on the OH and it get connected to the carbon plus, and it breaks apart, and you get acetone, this acetone, and phenol. So it is a method for the preparation of phenol, but the byproduct is acetone. So a lot of questions are asked on in NEET many times, in JEE NEET. Okay, every time what is the byproduct? Because everybody knows that it is the preparation of phenol, and as the name is indicating. But what is the byproduct that is formed with this? That also you need to know, right? So I hope it is clear. Any doubts in this? Yeah, Memuna, is it clear?
Yes, sir.
Okay. So let's do some questions. Yeah, this is just a recent question. Which intermediate you get when you react this isopropyl benzene with oxygen? Yeah. This is cumene and this is oxygen. So the answer is going to be cumene hydroperoxide. Just put the O2 molecule between the cumene and the hydrogen. But with which hydrogen? The hydrogen on the carbon which is directly connected to the benzene. The carbon of the carbon atom which is directly connected to benzene, alpha hydrogen. Yeah, so what's going to be the answer of this problem? Direct question and very recent from NEET. Yeah,
Option C.
yeah, option C is going to be the right answer. Correct. Direct question. Just you need to this hydrogen is the most reactive because this is benzylic hydrogen. Okay. And this is again from NEET 2018. So it is a very important reaction. Okay, so continuously it has been asked. So this is not the direct cumene which is given. This you need to prepare indirectly by doing Friedel-Crafts alkylation. But there is an important thing which you need to remember. The characteristic of characteristic of Friedel-Crafts alkylation, very important thing. I can tell you always check for the rearrangement. Okay, because the Cl is going to get removed, the cation is going to get formed, and the cations have tendency to undergo rearrangement. Yeah, so what's going to be the answer to this problem?
Option B.
Option D, yeah. Okay. This is the cation is going to form here, but this you are not going to put the cation as it is on the benzene because the cation will get shifted is that is known as rearrangement. Let me know, okay, if anything need to be explained. Okay. And this finally cations get attached from the middle point. So this is isopropyl benzene, right? Though you started with the normal propyl, but it has undergone rearrangement. And then it will be O2 and H2 plus, that is phenol and acetone, right? Option D is the correct option, right? So very recent question, direct question. So it is very important, and the same is in JEE also, but same, it has been asked many times, so it is very important. So do remember everything. Okay, now we move to the acidic nature of alcohol. So what do you think that which alcohol is going to be the most acidic and least acidic, and how you decide? Any idea? Actually, for alcohol, not only for alcohol, for any other compound, whether you study carboxylic acid, whether you study, okay, aldehyde ketone, okay. Suppose if we talk about acidic strength, so what we do, we remove H plus. And what do you get after the removal of H plus? What it is known as? The thing which you get after the removal of H plus, it is known as conjugate base. So whether someone is going to give H plus easily or with difficulty, that depends upon the nature of the conjugate base. So you might have studied this, that a strong acid will have stable conjugate base or weak conjugate base or vice versa. Okay. So this H plus is going to come out easily, right? If this conjugate base is stable. If it gets stabilized, the H plus is going to come out very easily and your alcohol is going to be very acidic. Okay. But what makes it stable conjugate base? What makes the conjugate base stable or unstable? You need to check the number of alkyl group, and alkyl group are not electron withdrawing, they are electron donating groups. Okay. So that is called plus because they are not very electronegative. So if you have electronegative groups on the alcohol, it is going to become more and more stable. The conjugate base is going to become more and more stable and it is going to lose H plus very easily. Okay, but if you have electron giving pushing groups, just like the alkyl groups, then this is not going to give H plus because then the O minus is going to become more and more minus. And if it is becoming more and more minus, why it will give H plus? H plus is not going to come out from the O minus. Is it clear? So tertiary alcohols are least acidic. So the thumb rule is if you are going to break this bond, so it will be maximum for primary, then for secondary, and then for tertiary. Acidic strength decreases. Is it clear? And what is pKm ammonia? How it is calculated? Yeah. Any idea? Actually, you calculate the equilibrium constant Ka. Okay. And if the alcohol is more acidic, it is going to be in the more dissociated form. Means the reaction is going to be more in the forward direction and it is going to be having more Ka. Okay, dissociation constant. This is known as dissociation constant is going to be higher, more and more. But if you want to calculate pKa, what you do, you take the log of Ka. Okay, minus log of Ka. So what we did here is that we first of all we used log and minus. So suppose because if we put minus, a larger number will become a smaller number. So if it is going to be more acidic, the Ka value is going to be more and more. Is it clear? The alcohol will more acidic means more dissociated. Alcohol will be more dissociated. Okay, and so equilibrium will be more towards the right hand side. So K is going to be more. But if K is going to be more, pK is going to be less. So stronger acids will have lower pK values. Is it clear? Any doubts in this?
No, sir.
Okay. So you can see the HCl is having pK -7. It's very strong. Okay. And this acetic acid is not that weak. So it is 4.8, methanol 15.5, water is 15.7 pK. So as you are moving towards alcohol, more and more branched alcohol, the pK is going to increase and acidic strength is going to decrease. So this is going to be weak acid. right? Because the pK is highest, and why it is going to, from the structure you can make out, because there are so many alkyl groups. These alkyl groups are electron pushing groups, and because they are electron pushing groups, they will not they will make O minus more minus, so H plus will not come out. Okay, you need electron withdrawing group. If the electron withdrawing groups are present, the acidic strength is going to be more. Okay, so if you compare the acidic strength of phenol and cyclohexanol, which is more acidic and why, can you tell it to me in the form of a statement? It is written here, explanation is given. You can give me the explanation in the form of statement also. Any idea?
Sir, can you repeat?
Yeah, what is the reason why phenol is more acidic than cyclohexanol? Why phenol is more acidic?
I guess because of the more phenoxide ions in it.
Yeah, yeah. So you need to look at the conjugate base. Okay, you remove H plus, and if the conjugate base somehow make itself busy, but, or I should say that if it becomes stable, then it will let the H plus go away. And here the minus is it is stable and it is getting stabilized. It is stabilizing itself, and how it is stabilizing itself? By getting involved in delocalization with the double bond of the benzene ring. Okay, so the minus charge gets into the benzene, it comes at the ortho position, para position, ortho position. Okay, and that's how it becomes its electron density, which was formed on O minus, that got dispersed on the benzene also. And if it got dispersed on the benzene and O minus, it will become more and more stable, and it will not combine with H plus. It will let the H plus go away. So it is phenol is slightly acidic in nature because its conjugate base phenoxide ion is stabilized by resonance. That is the reason. But cyclohexanol, what will happen? Cyclohexanol, if you remove H plus, you will get O minus. Okay, and this O minus is not going anywhere. Okay, it is just, it will be there wherever it is formed originally. Okay, it will be on O minus. That's it. It is not going anywhere. Okay, because it is not resonance stabilized. There is no double bond where this minus, so it will become unstable. And if it will become unstable, then it will get connected back to, it will attract H plus back. So it means what? So it was, cyclohexanol has stronger conjugate base, unstable conjugate base, which is not stabilized by resonance. Conjugate base. So that's why it is a weak acid. And phenol, the conjugate base of phenol is phenoxide ion. This is the phenoxide ion. That stabilize itself by doing the resonance. Okay, and that's why phenol was acidic. Phenol is slightly more acidic than water. If pK is 10, you can remember, roughly around 10. It is more acidic than water. Okay, this is the reason. But this is very important, that resonance structure you need to have them in your mind always while doing the reactions of phenol. That is very, very important. Okay, so because if you have substituted phenols, how the acidic strength is going to change? So this is metanitrophenol and this is paranitrophenol. Yeah, how the acidic strength is going to change? Which one is going to be more acidic? Yeah, Maimuna.
Second.
Which one? Paranitrophenol. And what is the reason? Now, how will you explain?
Because it
Yeah, because
has more phenoxide ion.
yeah, the phenoxide ion is more resonance stabilized. So it comes at ortho position. The minus charge comes at para position. It goes again at ortho. But when it comes to para, there is one NO2 group and it can come on oxygen also. So there is actually a extra resonance structure which due to which the minus charge of O minus, because NO2 is suitably placed. And I should say that this NO2 is also taking away the electron of the O minus, though it is far apart. But it is because the electron get shifted on the adjacent pi bond here and then here. So and now they will come on the nitro group. So it is more resonance stabilized. Okay. So nitro group is pulling electron by the means of resonance. So it is exerting minus R effect or minus M effect. Okay. Mesomeric or resonance effect. If someone is pulling electrons by the means of resonance, it is minus R or minus M effect. And this is going to make the O minus more stable, because now the O minus electron density is dispersed at more places on the nitro group also. So this is more stable conjugate base. After removal of H plus, the O minus is more stabilized, so it can release H plus more easily. And I told you the electron withdrawing group will make the phenol more acidic. But the electron withdrawing group need to be placed on the phenol at suitable position. Then only it will help. Otherwise, it will not help. Okay. So for example, if you have metanitrophenol, then it is not going to help much. Because the minus charge you can see here, it will come on ortho and para. It is not going to O minus charge of O minus. It is not going to come on the nitro. Okay, so there are not many resonance structures. Is it clear? So that's why it is very stable. And let me ask a very famous question, very famous, very common, as common as we discussed that cumin hydroperoxide method, and I've shown you that it was asked consecutively in NEET examination. Okay, so you need to tell me the order of acidic strength of these phenol molecules. This is orthonitrophenol. This is metanitrophenol. And this is paranitrophenol. And this is 2,4-dinitrophenol. And this is 2,4,6-trinitrophenol, which is also known as picric acid, common name. The most standard question of phenol. Decreasing pK, or what you can do, you can write the acidic strength and do it reverse. So acidic strength order is just the reverse of pK. Clear? Question?
Yes.
Decreasing pK order you need to tell me. So one thing is clear is if you are going to have more nitro groups, the phenol is going to become more and more acidic, and the pK is going to be lesser and lesser. That is clear. But the confusion is only with respect to, I want to know the main thing which I want to know is the acidic strength of B, C, and D. That is the most important part. So you can write the acidic strength first and then you can reverse it. So what's the order?
Is it F, E, B, C, D, A?
So decreasing is F. Acidic strength order or pK order?
Acid.
F and then E. Yeah, then
B,
B, then
C.
no. Actually, this is also need slight correction. I will tell you just in a while. So most people give this answer, and this is last is A. But here also it needs slight correction. The correction is actually this is among B and D are more acidic first of all, because you can see the resonance structure. If the nitro group at ortho position also, suppose if I put NO2 group at ortho, it can pull away the electron of the minus. Okay, and para also it can pull away the electron of the minus phenoxide ion, right? So ortho and para group nitro position at ortho and para position is going to make the phenoxide ion more and more stable. Okay, so
Yes.
yeah, so I need to choose B and D first, but most people say B because B is NO2 group is close. Okay, and because NO2 group is closer to OH group, it 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 pulls the electron more strongly from the O minus, and that's why the B should be more acidic. It is minus I is more, minus R is there. Okay, and someone will say that nitro group, the minus will come on NO2 group in D also, so D is also so more acidic. But D is being bit farther. So some people will say that okay, D is not going to exact, the minus I is going to be less. But that is true. But the correct answer is, and but in this C is going to be less acidic than B and D because nitro group is at the meta position. So it is not going, the minus charge is not going to come on nitro. Clear?
Yes.
So, but the answer is not this one. Answer is F is correct, E is correct, D is more acidic than B. This is very, very important. You need to remember. So all that explanation which I gave was correct. But then why is B is less acidic than D? In B and D, they are more acidic than C because in B and D, the nitro group is going to participate in the resonance. Okay. But it is because of the intramolecular hydrogen bonding. In orthonitrophenol, what happens is the OH actually, NO2 is very close to it. That will help the OH to come out. But there is one more thing which is preventing the H plus to come out, and that is the hydrogen bonding. This this H plus get attracted by O minus, and due to which it is held more strongly and it doesn't come out, okay, easily. So that is the reason why it comes out less easily than the para. So this is this is not the answer. This is the answer F, and you have E, then D para isomer, then ortho, okay, and then you have C, and A doesn't have any anything. So I hope this is clear. This is the acidic strength order. pK order will just the reverse. Okay. Clear? Any doubts in this? Very, very important.
No.
Actually, most people make mistake here only in B and B. So B is more acidic. It was expected to be more acidic because NO2 was closer, but then why the H plus was not coming out easily? Because of the intramolecular hydrogen bonding. Okay, there is one more thing which is very famous due to this. So what is the boiling point of orthonitrophenol and paranitrophenol? Which is going to boil at higher temperature? This is also very common. Yeah, tell me. Which one is having higher boiling point?
Paranitrophenol.
Yeah, paranitrophenol is going to be having higher boiling point. It is because the paranitrophenol, the molecules are connected to one another, right? Because by hydrogen bonding, and that is which type of hydrogen bonding? Intermolecular hydrogen bonding. Okay. So the molecules get connected to one another, but in orthonitrophenol, what happens is each molecule is separate, independent, because it is doing its own hydrogen bonding within the molecule, that is intramolecule. So it is not uh, participating in hydrogen bonding with others. Okay. So it is sort of independent. So if the molecules are independent of one another, they are going to come out very easily, right? So that is the reason why paranitrophenol is having higher boiling point due to intermolecular hydrogen bonding, and ortho is having lower boiling. So chemical reaction of phenol. Yeah. So nitration. So how you are going to do the nitration? How you normally do the nitration? Tell me. Nitration. What is the nitrating agent for normal molecules? What you take? You take HNO3 and H2SO4. But here then why you took HNO3 only? Why you have not taken H2SO4? Yeah, Memuna, any idea?
We normally take H2SO4.
No. Why we have not taken H2SO4 here? It's not there. Why? What is the reason? What you said? Actually, the reason is, so why you take H2SO4? If someone wants to do nitration, why can't we only use HNO3? That's the question. So can you tell me what's the reason? What is the use of H2SO4 in nitration? Yeah, Memuna.
Like to stabilize the molecule or something.
Actually, what happens is nitration is carried out. You need to have NO2 plus. That NO2 plus goes and attack on the benzene ring. Okay, that is the actual species intermediate, active intermediate, which goes and get joined to the benzene. So, but from the HNO3, you need to generate that NO2 plus. And how you generate NO2 plus? You need to remove OH water. Okay, but how you will remove water? You need to take some acid which absorbs water. And H2SO4 is the best acid which can absorb water. It gives its own H plus and it takes away the OH and you get NO2 plus. So you take H2SO4 to enhance the concentration of NO2 plus, because HNO3 on its own it is not going to break into NO2 plus. It's very less. Okay. So you need some H2SO4 which facilitates the removal of OH group from the HNO3 and which actually helps the formation of NO2 plus, and that NO2 plus is very reactive and that goes and get connected to the benzene. So that is the reason why we need H2SO4. But if we, so H2SO4 facilitate the removal of water OH from HNO3 and thus it help in formation of NO2. So always remember, if you are doing nitration, you take HNO3 and H2SO4, but here you don't require H2SO4 because this phenol is very, very reactive. On its own, it has very high electron density because of this. Okay. So if its electron density is already very high, it means what? It means you don't require more NO2 plus concentration. So whatever the NO2 plus concentration is generated by HNO3 on its own, that is sufficient to carry out the reaction. Because the substrate which you have taken, which is the phenol, is very reactive and it can react with even with a very small amount of NO2 plus. So that's why you take only concentrated dilute HNO3, not also concentrated. Because look here, what has happened if you have taken concentrated, because again, if you have taken concentrated means what? You have increased the concentration of NO2 plus. And if you have increased the concentration of NO2 plus, the reaction is going to happen at all the places. Because you know, just now we have seen that these places are very much electron rich because of the resonance. So all the three places you have NO2 group connected. Okay, so that's why you need to take dilute HNO3. Suppose if you want to connect the one NO2 group either at ortho and para position, you need to take dilute HNO3. Okay, so that will not give the NO2 plus in surplus amount, so it will just only one NO2 will get connected either at ortho and para. Phenol is ortho para directing because of the negative charge, which appear due to resonance. Is it clear? Any doubts in this? But if you take HNO3 and H2SO4, that is going to be a disaster kind of thing, because that is also strong oxidizing agent, and phenol is very electron rich and it will get oxidized. Okay. So that also you need to remember. Yeah. And bromination, this is very, very important. Is it clear? And this is a test for the phenol. So when you take bromine water, you get white PPT. Clear? But if you take bromine and carbon disulfide, only one bromine get connected at a time, either at ortho and para position. Why? What's the reason? This is also very standard question asked many times. Yeah. Yeah, Memuna.
Um,
So why only one BR is getting connected, and why only why three BRs are getting connected? This is bromine and water. Okay, let me write it completely. And this is bromine and carbon disulfide. Okay, so carbon disulfide is just like CO2. It is a non-polar molecule. Why it is non-polar? Just like CO2, it is non-polar. Why it is non-polar? Because both sides you have sulfur and it is same. So it is a liquid and it is a non-polar liquid, just like oil. Oils are non-polar. Okay, and you might have studied many times in your junior classes also that like dissolves like. Okay, and if it is non-polar, it will not let the phenol. Non-polar means it is not having charges. Okay, so it will not let the phenol to ionize, because if it ionizes, it forms charges O minus and H plus. That can't happen in carbon disulfide. Carbon disulfide is a non-polar solvent. It will not let the phenol to undergo ionization. Because non-polar means that it doesn't have charges. So it will not entertain plus charge and minus charge. Okay. So phenol will remain phenol, and if it remain neutral, it is still electron donating, but not very much electron donating. Okay. It is like this. A minus charge will still circulate, but not up to the extent which by which it was circulating in phenoxide. So what happens over here? So you have taken phenol in water. Water is a very good solvent. It is a polar solvent because it is having H plus and O minus. So phenol get ionized in this, and it forms phenoxide ion. Now look, there it was phenol only, here it is phenoxide ion. Okay, and you know this phenoxide ion is O minus, so it is very much electron rich. It is very electron rich, and it will undergo a resonance with the benzene. Benzene will have negative charges, very much, though negative charges are here also, but very high negative charges will be there on the phenoxide ion. As a result, all the three positions get reacted at a time simultaneously. Okay? So the reaction takes place at all the three positions in water. Is it clear? Any doubts in this? But this is a famous test for phenol. Okay. I hope it is clear, Memona.
Yes.
Okay, halogenation, yeah, this is same thing, right? And Remontiment reaction, how it is done? What is Remontiment reaction? You can tell me a few sentences about it, something about it. Yeah. What you know, you can tell me. I will explain it to you. No problem. It is formylation of phenol. Okay. What do you mean by formylation? Formal group is what? Formaldehyde is
Let
HC.
me explain.
Yeah. It is, first of all, Remontiment reaction is a formylation of phenol. Okay, what is formal group? This is formaldehyde. So formal group is C double bond OH. Okay, this is the formal. Right? So, and where the formylation occurs, it occurs at ortho and para position. Normally it occurs at ortho position because there are two ortho positions. So ortho positions are more in number. So you need to put the formyl at the ortho position. Okay. And the product is known as salicylaldehyde. Okay, which is the phenol, and there is a CHO group, formal group connected at the ortho position. Okay. Clear? So, what is the IUPAC name of salicylaldehyde? This is known as benzene carbonaldehyde. This is the main functional group, and this is hydroxy. Okay, because this is a higher priority functional group, so I'm going to use the suffix of this benzene carbonaldehyde and 2-hydroxybenzene carbonaldehyde. That's the IUPAC name of the salicylaldehyde. Salicylaldehyde is a common name. IUPAC name you can know. You can remember that it is 2-hydroxy. Means I need to do the numbering from this carbon too, because this is the main functional group aldehyde. Okay, so this is the basic thing. What is the reagent that we need to think? What is the reagent for this? So let me add a page. Okay, so the reagent of Riemann-Tiemann reaction is chloroform and base, NaOH or KOH. Okay, so what a base will do actually? What you know? The base removes HCl, right? Okay, so HCl will be removed, H plus and Cl minus. So if H plus is removed, you will have a minus charge left on the chloroform molecule, and Cl minus is removed because base removes HCl. So this minus, the Cl will take away the electron pair through which it is connected to the carbon, because it is electronegative. So you will have plus charge, but already there was a minus charge. Minus plus will neutralize one another, and you will have this kind of thing. So minus Cl minus, and this is the intermediate. What this intermediate is known as? Any idea? This is high. This is neutral, but that doesn't mean it will not react. It is a highly unstable reactive intermediate, and you can see, you can count the total number of carbon. There are 6 electrons. Total number of electrons on this carbon, that there are 6 electrons. So it is an electron deficient intermediate, and this is known as carbene. Okay, just like a carbocation, this is also an intermediate, dichlorocarbon. Is it clear? So this is one part of the story. The another part of the story is the phenol. And because phenol, you have taken it in basic medium, so it is going to form phenoxide ion. Right, and the phenoxide ion, you know, it is having the minus charge. You can write it like this also. You can write it like this also, because the minus charge is circulating on the benzene ring. Okay, you can write it like this also. But there are 2 ortho positions and 1 para, so I'm going to take this one. This is minus, this is nucleophile, and this is electrophile. This is the general way to write electrophile. So what will happen? This is going to give electron to this. Okay, so there will be a give and take of electron. Look here, what will happen? So if the electrons will be given, what you will be left with? You will be left with this. There is H already there, but it was not written. Now I am showing it because I need it for my reaction. Okay, and this CCl2, and this will become minus, and this will accept the H. The electron will get back into the benzene of the H plus. Because benzene, whatever the reactions you are doing, you need to get back your benzene ring, because that is very stable. So I need to, if I put something on the benzene, what I do, I immediately remove H plus from that position, so that the electron get back into the ring and give you complete benzene. Okay, so this will become CH, Cl, Cl. Okay, and now you are taking aqueous condition, aqueous NaOH. So what will happen? So aqueous NaOH will remove both the Cl Okay, and you will have the two OH groups substitution will happen, and two OH groups, and two OH group gem diol, you know, they are unstable, so water will get removed and you will end up with C double bond OH. So what are the intermediate? This is the intermediate. Okay, and this is the intermediate. This is the intermediate. So there are a lot of, this is phenoxide ion is also the intermediate. This is also the intermediate of the reaction. Okay, so finally when you do the acidification in the last step, you have that final salicyl aldehyde being formed. This is formulation of phenol by taking CHCl3 and NaOH. Is it clear? Any doubts in this? Amuna?
No, sir.
So there are same reactions like always reaction in which you take CO2. Though they are steady together, but they are different. So here this is the nucleophilic addition reaction. So this becomes CO minus and H plus is removed. You get, this is salicylic acid 2-hydroxybenzoic acid. Or you can take NaOH and CCl4. So let's continue it on the next time, right? Just let me know if you have any doubt. Okay, you can ask me any number of times, no problem. So we will do some questions related to remote even this